Hello friend, once again welcome on board, and today I am going to discuss about very interesting topic A321 air conditioning system Airbus 320 family, and this is part 2. Part 1 is already released and it is available on my channel. How the aircraft stay cool, just general idea about the aircraft system. Please go through my channel for part 1, and this is very useful, especially for those people who is new from the college, who is joining the Airbus 320 family maintenance. This is also useful for the experienced people also who want to just refresh the knowledge about the air conditioning system. So guys, don't forget to watch this video till end for better understanding, and hit the like and subscribe to this channel for getting more video on Airbus 320 family, and the link is available on the display. And let's go with the air conditioning system. So air conditioning system and how the temperature is controlled and modulated in the cabin and cockpit. Here we'll discuss about the temperature regulation because I am going to focus on this point only. This will cover in the next part. So the flow of hot air from the air bleed system is regulated before it enter in the pack order to regulate the temperature. Hot air pressure is maintained above the cabin pressure, which let the hot air flow join the pack air supply when necessary. Part of the cabin air is recirculated, decrease the air supply demand. There is a air cycle machine which has turbine, compressor, fan, cools the air. Main component of air cycle machine is this 3 component, and this is mounted along the shaft. This is very good to know information. Turbine, compressor and fan mounted on along with the shaft. So this is the pack 1-2 location. It is available on the belly fairing on 320 family aircraft. So this is the location. This will discuss in the video. RAM air, emergency RAM air inlet, and this is your recirculation filter, HEPA filter, you can say Corona filter, and there is a recirculation fan. This is your mixer unit. This all equipment is located in the forward cargo. If you will open the forward cargo, go inside, and rear side there is a panel. There you will get access about the mixture unit. So this is your basic system, and we'll discuss slowly so that you will have better understanding about the component. So air conditioning system is fully automatic. It provides the continuous air renewal and maintain a constant selected temperature in the following 3 zone. What is the following 3 zone? This is the 3 zone: cockpit zone, forward cabin zone, and aft cabin zone. You'll see that, just see the color of that zone. Here you will have bluish and pinkish. You can say the color zone, because depend on the area how the temperature, how the air conditioning is working on the area. That's why temperature will be little bit hotter on the rear side, mid will be little better, and cockpit will be far better. So all everything is controlled from the cockpit. We'll discuss one by one. So there is the 3 zone. I told about the 3 zone, that is cockpit, forward cabin and aft cabin. All are controlled by the from the cockpit air conditioning panel. There is a 3 separate switch to control this temperature, and air is supplied by the pneumatic air system via 2 fact blower. Here you will get bleed air, and via 2 pack flow control valve, FCV, we call the FCV. You can see there is a for both pack, there is a different FCV, one for pack 1, one for pack 2. And air is then distributed into the cockpit cabin via the mixer unit. So after pack it will go to the mixture unit, then it will go to the cabin area. Again we'll go in detail. There is an emergency RAM air inlet that can provide the ambient air to the mixture unit during the emergency situation. And temperature in the flight deck and cabin can be selected from the cockpit air conditioning panel. This also will come into the next slide. Pack operation is completely controlled by 2 air conditioning system controller, that is ACSC 1 and 2. You can see there is a 2 computer who is handling all the situation. A temperature control panel is also available on the forward attendant panel, that is FAB. If you are entering from the L1 door, you'll find out left side there is a FAB. From there you can adjust the temperature in flight around plus minus 2.5 degree only. That is access to the cabin crew for adjustment of the cabin. And there is another, you can use low pressure ground cart for on ground, providing the condition air to the cabin if APU is not available, or APU is switch off, or maybe APU is unserviceable also. So here you can say little more in deep about the schematic diagram. We'll cover only air conditioning system, not avionics or cargo ventilation system. So this is your pack 1 unit. Further we'll go in detail in the next slide about the pack, what are the components is there, how it is working, how air is getting chilled. So if you'll see behind the FCU flow control unit, or you can say FCV flight flow control valve, there is the engine bleed can be used for to supply the bleed air for the both pack, any one engine, or you can use cross bleed also, then you can use APU bleed also. So there is a multiple source, and there is a LP ground cart in case of both engine is shut down or APU is unserviceable, then you can use a ground air conditioning unit. And there is the emergency ram air inlet. If a differential pressure is less than 1 psi, then only this ram air inlet will work in flight, as well as if required on ground for the operation test, you can do by pressing the ram air inlet push button. So this will connect it to the mixer unit about the emergency ram air inlet. Then now you'll see bleed air is going, pack is decreasing the temperature, and then going to the mixture unit, then it is going to the cockpit area, going to the forward cabin area, going to the aft cabin area. Now if you see, there is a one more tapping above the flow control valve. You can see, you will see in the previous diagram, this is your flow additional tapping above the flow control valve. We are taking to the trim air pressure regulating valve. This is also available near to the mixture control unit, and then it will distribute it to the cockpit area, forward cabin area, aft cabin area. So this can be independently controlled from the 3 position switch. So you can mix the hot bleed air with the to the mixture unit, and then it will control the temperature. And this is your cockpit temperature, zone temperature. This is forward cabin zone temperature, and this is your duct temperature. So down is all our duct temperature, and above one is top one is all our zone temperature. So here also you can see same, it is going to the hot air manifold, to the trim air pressure regulating valve, and then it will divide it into trim air valve. And here you can see duct temperature is installed onto the all the duct. And this is your control. Now we'll discuss in the panel about all the switches. So just general idea, this is for cockpit, this is for cabin, and this is for aft cabin. Already I have uploaded video on my YouTube channel, but from there you will get this temperature adjustment, and forward is for forward, aft is for aft. So this is the main component of you can see air conditioning unit or air cycle machine. We'll cover this one by one, and first we'll go quickly, then we'll go in detail. What happen, hot bleed air will go to the pack control valve. This will go to the primary heat exchanger, where the temperature will reduce, and it will go to the compressor section, where pressure and temperature will rise. Again, to decrease the temperature, it will go to the main heat exchanger, then it will go to the reheater. Outer casing, you can see there is a necessary line we'll discuss, and outer casing, then it will go to the condenser, then it will go to the water extractor, then water extractor, there will be the water tapping, it will inject it to the ram air inlet area. You can see during walk around there is a water spray into the ram air inlet area. This is the water, that water is coming from water extractor, not from the water tank. So always keep in mind this, someone can ask during audit time, what is that water, from where this water is coming. So this is the from the water extractor of the pack. So further it will go to the reheater, internal lines, go to the turbine, then turbine will rotate this compressor, and temperature will go to then temperature will reduce, and it will go to the mixture unit, to the check valve to prevent the depressurization of aircraft. There will be the check valve, then it will mix to the this mixer unit, what I called, this is your mixer unit. So we'll now go one by one component. First we'll talk about the flow control valve, FCV, that is very important. And before that FCV, there will be ozone filter to reduce the carbon monoxide into the pack. So there will be one more filter, and it is not showing here, but there will be the filter with the FCV. Discuss all the pack component one by one. Flow control valve, high pressure air is supplied to the air conditioning system from the main pneumatic system. This air goes through the two ozone filter. What I told, it will go to, from the ozone filter, and two flow control unit. Both two packs are there. There will be two flow control unit, and there is a two ACSC control computer. So from ozone filter and two flow control unit to two identical independent air conditioning kit. Think about, there is the full form per pack: pneumatic air conditioning kit. The FCB valve is pneumatically operated and electrically controlled. It regulates the airflow in accordance with the signal received from this ACSC computer. This will regulate the flow, and will go further in the absence of if there is a no pressure upstream of the FCB. This will spring loaded into the closed condition. So this is just good to know information. Valve will be closed if there is no pressure, and FCB valve will close automatically in case of pack overheat on ground. If there is overheat warning, automatically this FCB valve will close. On ground only, during engine start, FCB valve will close. Operation of the fire or ditching push button, this FCB valve will close. So many interlink with the system. Just quickly, we are going on the deep knowledge, so better to understand everything, all the all the component. This will boost your knowledge. All are controlled from the air conditioning panel, and this will discuss regarding panel. Will discuss in the last slide. So there is a heat exchanger. Bleed air is ducted to the primary heat exchanger, then compressor, then it will go to the main heat exchanger. Heat exchanger means what? It is reducing the heat. How it is reducing heat? From ram air inlet there is a airflow, and there is a this fan will rotate. This will suck the air, and it will bypass over the heat exchanger, and then it will exit from the ram air outlet. This fan will work on the differential pressure. In if aircraft is in flight, this will rotate on differential pressure, and as I told, water extractor also will inject air from the water extractor. Water will come, and this will also utilize to decrease the temperature. Now if you go to the condenser, what is the purpose of condenser? Condenser is tubular heat exchanger with tube to tube discharge heat exchanger that cools the air below the dew point to remove the moisture and facilitating the efficient dehumidifications. So this will cool the temperature before going to the next step. And there is a reheater also, reheater that heat the cold and moisture air coming from the water extractor before entering the SEM. So once it is cool, water extractor will remove the water and it will inject air, and whatever molecules of air will go to the reheat exchanger. Now here you can see necessary tube to tube. Why they are taking example? So it is going from the internal tube to the turbine section, and reheater you can see there is a hot bleed air surrounding that, so that will absorb all the moisture. This will remove all the moisture from the water. Compressor compress that. This will increase the high pressure and temperature. And if you talk about the turbine air expand in the turbine section, which result in a very low turbine discharge temperature. Now if you talk about the compressor, compress the high pressure. Compressor will compress the high pressure and temperature. And turbine, what will do? Turbine air expands in the turbine section, which result in very low turbine discharge air temperature, and the turbine drives the compressor and cooling fan. So this will discharge very low temperature, and this will drive the compressor and this fan. And there is a bypass valve, you can see just near to after primary heat exchanger there is a bypass valve. What is the purpose of this bypass valve? Is to operated by the electromechanical actuator. There is a electromechanical actuator to modulate the pack discharge temperature by adding the hot air. If temperature is going beyond the limit, there may be ice formation, there may be chance of turbine damage. So this bypass will automatically adjust. There is no particular switch to control this. Automatically it will modulate, and it will mix the hot air with the turbine exhaust discharge point. So this is very good to know information about that. And there is the ram inlet air inlet flap, which will modulate the airflow through the exchanger, which already we have discussed. And then about the mixture unit, if you will talk about the mixer unit, we'll just go to about the mixer unit. Mixer unit mix the cooled fresh air from the pack with the cabin air being recirculated through the recirculation fan. So this is your recirculation fan. There is a filter, that is called HEPA filter, and there will be the check valve. And what we is doing, mixer unit mix the cold fresh air from the pack with the cabin air being recirculated through the recirculation fan. Airflow out of the cabin through the lower sidewall panel, that is dado panel you can say, to the underflow area, and mixer mix with the fresh air from the air conditioning pack in the mixer unit. So recirculation fan will draw all the air from the underflow area, and this will mix into the mixer units. This will reduce the bleed demand of the pack, because you are utilizing the same air. So this is also very good to know information about the recirculation fan. And this mixer unit, already I told, is connected with emergency ram air inlet. And then next we'll go about the pressure regulating valve. This is also pneumatic operate and electrically controlled valve, regulate the hot air pressure, and this is controlled by the ACSC1 computer. You can see this signal is going to ACSC1. Valve close upon pressing the hot air push button, and this will close automatically if the duct overheat temperature happen, or cockpit trim air valve fails, or both cabin trim air valve fails. This during this situation, this valve will close automatically. Trim air valve, regarding this trim air valve, if you are talking, trim air valve also electrically controlled by the zone control computer, that is ACSC, and cockpit trim air valve is controlled by ACSC1, cabin trim air valve is controlled by ACSC2. So if you are seeing this computer, how it is going diagram, this is going to the cockpit. ACSC1 is controlling only trim air valve 1, and taking ACSC1 only getting input from the cockpit area zone temperature area to ACSC1, and forward cabin and aft cabin area temperature is going to the ACSC2. Already I have uploaded video about the temperature sensor of the cabin and cockpit area. And here you can see trim air valve for the forward cabin and aft cabin is controlled by ACSC2, and pack 2 is controlled by ACSC2, pack 1 is controlled by ACSC1, and same FCV also controlled by ACSC1, and pack 2 FCV is controlled by ACSC2. So this is just general schematic diagram, and hope you have understand very nicely. This is your hot air push button. We'll go in detail about this panel in the last video. So here you got complete information about the air conditioning system. Now if you see the pack, if you are opening the pack panel, you will get like this component. It will be, then if you compare with the schematic diagram, you will not understand, but that's why I have created this image, and this will be very useful. This is the Airbus 320 family fuselage, and here you can see this is your ram air inlet, this is your pack air inlet, this is your pack 1, this is your pack 2, this is pack 1 outlet, this is your pack 2 outlet, and this is the panel for pack 1. So this is your just for information what are the component are there. So ram air outlet, this is your ram air inlet, this is your ram air inlet. Then water spray, if you see from this area inlet, you will get water spray. You can see water spray is going to the water extractor. This is your water extractor, this is your reheater, this is your condenser, this is your plenum chamber, and here only you see the fan is rotating, and this is your primary heat exchanger, main heat exchanger, and I told about the bypass valve. This is your bypass valve which is going to mixing to the turbine section. So this will this will reduce the temperature. So any component left, almost I have covered all the things. So guys, we'll take a break. So here we'll discuss about this air conditioning panel available on the overhead panel. You can see the name of the 88th chapter, air conditioning, and what are the control will correlate with this. So if you talk about first point, this is your zone control selector, that is cockpit zone, forward zone, aft cabin zone. So this is for cockpit, one for cockpit, forward cabin, and aft cabin. There is a 3 position of cold, 12 o'clock, and hot. Cold it will be on 80 degrees Celsius, and 12 o'clock it will give 24 degrees Celsius, and hot if you are selecting hot, then it will go give 30 degrees Celsius, and this will maintain the cabin temperature. And there is a hot air push button. This valve regulates the hot air pressure. If you are selecting on, if you are selecting off, valve will close and trim air valve will close, and false circuit can be reset with this initially. Fault light will come on amber along with the associated ECOM warning when the duct temperature, there will be the duct temperature is there. When the duct temperature is overheat or duct is overheat, then you'll get fault light. And you can see on off means just on off. Valve will regulate the hot air pressure. If it is on, if it is off, valve will close and trim air valve will close, and fault circuit is reset. When fault light will come here, fault light will come on amber color along with the associated ECOM warning when the duct overheat is detected and temperature reaches to 80 degrees Celsius. If duct temperature reaches to 88 degrees Celsius, then this fault light will generate. And during that time, valve and trim air, trim air pressure regulating valve and trim air valve will automatically close, and this fault light will automatically goes off when the temperature is dropped below the 70 degrees Celsius or selected by the cabin, by the captain. So if you are selecting off, this fault light will goes off, or if temperature is automatically going below the 70 degrees Celsius, then this fault light will goes off. If you will talk about the pack 1, pack 2 push button, here also on and off. If you are selecting on, pack flow control valve is automatically controlled via computer, ACSC 1 and 2 for the both, and if you are selecting off, then it will go off. When the fault light will come on the pack 1 or pack 2, this will come on amber color and caution appear on the ECOM if the pack flow control valve position is disagree. So there is a lot of sensor. We'll discuss separate in short reel about the pack flow control valve. So if there is a disagree with the position of the pack flow control valve, then you will get ECOM warning, ECOM caution warning, and fault light will come. Or you can say in case of compressor outlet overheat or pack overheat also is coming, then this fault light will come. Now if we'll talk about the pack flow control valve, permits the selection of the pack valve according to the number of passenger and ambient condition, smoke removal, hot or wet condition. So here also you will see low and 12 o'clock, normal and high. Low means 80% and normal means 100%, high means 120%. Manual selection is irrelevant in the single pack operation. Suppose on ground you are selecting high or you are selecting low on ground, so you are selecting manually, means you are using maybe you are using APU bleed supply, then this will give automatically 100%. Okay, so manual selection is irrelevant in the single pack operation or with APU bleed. In the case it will go to the automatically in the high condition. So single pack operation and with APU bleed, whether this knob position is on low, it will supply high only. Low is selected, the pack flow can automatically selected up to the 100% when cooling demand cannot be satisfied. So if you are selecting low 80% and cooling demand is not satisfied, then it will go automatically to the 100%. And there is a ram air push button. If you are selecting on, light will come on white color on, and as a lot of condition is there, differential pressure is less than 1 psi, then only this ram air inlet valve will work, and make sure that time pressurization control is in automatic mode. If it is on manual mode, then this ram air inlet valve will not open. And this is your APU bleed valve. Once APU is running, we'll select the bleed on. If in case of here also you'll get fault light, same condition. And this is the ground cart where you are connecting for this HP cart and anything else. And this is a cross bleed valve, set open auto. Normally it will be in the auto condition. If one engine bleed is in off in flight under ML, then it will go to will select in open condition, then it will supply to the pack 2 through cross bleed valve. So this is all about the overhead panel and how you can correlate with that. So almost this pack flow control valve for this, and this trim air valve for this 1, 2, 3, and this hot air valve for this trim air pressure regulating valve, and pack just giving indication signal to the ACSC, then this will control the pack complete operation. And this is for engine bleed. Once the engine bleed will be on only. If you want to off, you can off, depend on the condition of MEL. So this is all about the back panel. So this is your ecom condition page. ECP, from ECP you can control, you can open by pressing ECP condition page, and here this is your cockpit zone temperature, forward cabin zone, aft cabin zone. This is your duct temperature, and this is your trim air valve, that is cold or complete close condition, hot if open condition. Zone temperature, if going above the 80 degrees Celsius, then this will become amber, you will get fault light on the pack. This will become if temperature is will go above the 80 degrees Celsius, and it will become normal if temperature is going below the 70 degrees Celsius. And anything else, this is your hot air push button, on off condition. So this is all about the condition page. Okay, nothing else additional to need to discuss. There is some fault in cabin recirculation fan, you will get fan amber color written here on the above that. So this is also very good to know information thing. Now come to the ECP ecom control panel bleed page. So this is your bleed page, and here only we will cover this air conditioning system only, this portion. This is portion for the engine, and this is your cockpit cabin, and this is aft cabin of mixer unit. It is going to the mixer unit, and this is your pack outlet temperature 25 degrees, just for example. Normally it will be in green color, this will become amber if it is above the 90 degrees Celsius, then you will get fault light on the pack 1 push button. So this is also good to know, if it is going above 90 degree you will get fault light. So zone duct temperature is more than 80, fault light, and pack outlet temperature, if it is more than 90 degree, then it will be fault light will generate here. And this is you can see here, that is your cold valve is fully closed and hot valve is fully open. This is your bypass valve position, this will be in normally green color. So there is no separate push button for showing this bypass valve condition. And third one is your this pack flow control valve. So pack flow, normally it will be green, and this will become amber if pack flow control valve is closed or disagree with the position, then you will get amber light. So yeah, there is so many condition about the valve not close. If this is a condition, valve is not closed, and disagree with control position, means you will get amber light, amber color. And valve is fully closed but disagree with the close position, control position, then also you'll get amber or amber warning. And valve is fully closed, so this valve is condition, this is your open condition, this will be like this, it will be in the closed condition. If it is in amber color in open or closed condition, means valve is fully disagree with the position, so then you will get amber caution on this particular valve. And this is your pack outlet temperature, normally this will be in the green color, this will become amber if the temperature is above 230 degrees Celsius. So this is 3 point where you get when you will get fault light. First is your 90 degrees Celsius for pack outlet temperature, and one is duct temperature 80 degrees Celsius, and another is 230 degrees Celsius if pack or compressor outlet temperature is going above that, then you will get pack fault light also. So this temperature indication need not require to remember the numerical value, I am just telling about the what is the concept, but it is automatically controlled by air conditioning control system. So whenever any fault or disagree position will come, temperature is rising above the requirement, then it will generate the fault and come warning. So this is your ram air inlet, and here also same valve condition, open, close, or not fully closed, or in transit position. This is all about the bleed page, and this thing will cover in another bleed chapter. So this is all about the ecom bleed page indication, and bottom is pneumatic indication. We'll discuss in pneumatic ATA chapter, and wait for the next part, that is part 3. We'll come up with the avionics equipment and ventilation system. And guys, if you really love this video, please don't forget to like, share and subscribe for getting more video on Airbus 320 family. See you guys.